Hi, PyClust is a toolkit that enables meta-learning repository creation for clustering. It consists of PyClustKit, a Python library that is optimized for calculating clustering validity indices and extracting state-of-the-art meta features for clustering. Additionally, it consists of PyClustUI, which is a graphical interface for creating meta-learning repositories and training meta-learner algorithms for algorithm selection. Okay, first let's start with PyClustKit, the Python library, which we can install with pip install PyClustKit. Here we're going to load the sample dataset, the iris dataset, and we're going to feed the k-means dbscan with default parameters just to showcase how the library works. If we want to calculate the internal validity indices, we have to call CVI toolbox from pyclustkit.eval, and then we have to call the calculate ICVI method, where we can define which indices we want to calculate, or we can leave it blank in order to calculate every one of them. If we want to calculate the meta features for the dataset, we have to call the mefextractor class from pyclustkit.metalearning and call the method calculateMef, which accepts calculating meta features based on the category they belong to, the paper they were presented, or by name. When we're done, we get a dictionary, and depending on what we have declared in the search meta features method, we'll get either the values, the names, or a full search over the supported meta features. This notebook example also showcases how to build your own meta-learning knowledge repository, but in this video we will continue to do so with the PyClustUI, the graphical interface to do so. However, if you want, you can check how you can do it programmatically in the project's repository examples folder. The homepage of PyClustUI provides easy access to your trained meta-learning models from within the PyClustUI, and it actually has three sections. The first one lets you ingest your data. Currently it supports CSV numeric datasets. Then you can calculate all the available meta features that come from PyClustKit. This includes descriptive meta features, statistical, graph-based one, landmarks, and so on. And you can also download them in the form of JSON. Afterwards, all you have to do is select one of the pre-trained meta-learners, and we'll see later on how we actually train them to get the result for our dataset. Now, in the case we want to populate our meta-learning repository or build a new meta-learner, we'll start by feeding different algorithms on the dataset at hand, and we can configure in a JSON format which are the parameters that we're going to use in our space and what are their values. After the exhaustive search, the grid search has concluded, we'll see a couple of plots that show us what kind of algorithm was found the best among the configurations we tested. Then we can select any single CVI in order to visualize our dataset after dimensionality reduction in case more than two features are available in the dataset. So now that we have concluded with meta feature extraction, remember we did this in the first page of the PyClustUI, and we have also searched some configuration. It's time to actually train a meta learner for algorithm selection. Two models are currently supported for this job. This is the k nearest neighbors and decision trees. The first one is chosen due to efficiency and simplicity, while the latter is chosen for its ability to provide explainable results. After the training of the meta-learning over the repository has concluded, we can check some statistics about the algorithm that provided, and if we're happy with the results, we can provide meta-learning ID and add this meta-learning to repository, so the next time we go to the front page we see this result.